Mathieu. Hello everyone. So my name is Bruno. If you want to pronounce it like the French, you can say Bruno. I work for a cloud hosting provider based in Switzerland. The company is called Lightoscape. So I'm a developer there, and I work a lot with ops people, support staff, and mostly non-developers. We have a fairly large infrastructure with lots and lots of moving parts and different systems interacting with each other. And we need to know pretty much at any moment in time what's going on with the systems, like how the infrastructure is doing, how the apps are behaving. And not everyone is a developer, and basically SSHing into machines and doing some grep and tail commands are not acceptable solutions to find information about what's going on everywhere. So the goal for this talk is to set up a very solid visibility and visibility infrastructure for knowing what's going on with your systems and applications. We're going to look at three things, very quickly: errors, then events, and finally metrics. So errors. This is actually very easy. You just have to use Sentry. Who uses Sentry here? Okay, pretty much everyone. If you don't use it, then try it, and you'll never look back. Sentry is great. It will notify you when your code breaks. So it's, as a developer, it's a great tool. But you also need to know what's going on about things that are not broken, so in day-to-day operation. And this is when events come in. Basically, an event is a log call. So it's a timestamp information about something that you want to know about. So it's fairly easy to emit logs, and we do that all the time. However, searching on remote machines, when you have one machine, is already a bit annoying. When you have several, like tens or hundreds or thousands, it becomes a real problem. So how can we easily search for logs with a large infrastructure? The solution for that is centralized logging. So basically, on each machine or application, there will be an agent that forwards all your logs to a central aggregator. And that aggregator will store log entries and provide a search interface for easy access from anywhere. So that's basically what it looks like. Hosts run agents called log shippers, and the aggregator solution that we're going to use is the combination of Logstash and Elasticsearch. So Logstash will take a list of log sources and watch for them and basically dump every entry into Elasticsearch. And then there is a very powerful interface for visualizing Elasticsearch data, which is called Kibana. So for collecting logs, if you want to do things, if you want to get started quickly and you have rsyslog or syslog-ng, they can natively ship logs remotely. So it's very easy to set up if you can use rsyslog. If you can't, like pretty much every system can log to syslog, like Redis, Postgres, or anything can log to syslog. Nginx doesn't, for instance. So for that, you have to use a specific log shipper that will watch for a file and basically tail a file and ship logs to the aggregator. So one solution is to use Logstash Forwarder. There is also Logstash, which will running on the aggregator, but you can also run it on the host machines. The only drawback is that it can use a lot of RAM. So if you don't have that much memory, it can become an issue. And in Python, you can just use the syslog handler and send everything to syslog. once you have everything in one place, that's great. But we're storing logs in Elasticsearch, so it's a very powerful data store for searching for stuff. But it's also great for analytics and more powerful analytics than just search. So one way, usually when we log stuff, we format a string and call logging.info or whatever with that string. So it's great, but if we're going to send stuff to Elasticsearch, well, first of all, there's not much information into that line, and there is no structure. So we can do any of the advanced queries that Elasticsearch allows. The idea to fix that issue is to switch to structured logging, which basically means instead of treating a log record as a formatted string, you treat it as a set of key-value pairs. So in this case, an event, a user, an IP, basically any metadata that you want to attach to them. In Python, there is a very useful library which is called structlog that helps you do that. Basically, you can use it just as the standard logging library. And then when it emits records, they automatically get formatted as JSON. And that's very useful for Logstash because it can natively store JSON data, and it will be very easy then to search for, to do analytics on that information. One thing you can do also with structlog is to have contextual loggers that you can, for instance, at the beginning of a view, you can bind a logger to the currently logged in user. And then when you actually make a log call, it will also attach all the information that you have previously set up. So here, I'm not mentioning the user in that info call, but since I added it earlier, then it gets automatically inserted into the log payload. So that's basically the idea we have. We take structlog to format just JSON log entries, and then we store them into Elasticsearch. And now we have very rich data for building useful dashboards. So, last time I did a demo, the whole thing was completely broken. So I hope it works this time. I haven't started. So this is Kibana, which is the Elasticsearch, an interface for Elasticsearch. And here I'm looking at HTTP logs, basically what Nginx generates. So first of all, one thing that Logstash can do is that if you look here, this is the full log line. You can see it. But basically, that's the standard Apache log file. And with Logstash, you can split that into an actual structure. So you end up with a parsed log entry instead of having just a raw message. So it's basically structlog done the other way. So here I'm just looking at HTTP logs, and this is a web application that I run. It has an API and a web interface, and just using just looking at the URL for HTTP request, I can determine whether it's a request to the API or to the web interface. And we can do this directly with Kibana. And these are Lucene queries that go to Elasticsearch, and they automatically split our data into, here's the logs for the web interface, here are the logs for the API. Also, one thing I log as well as in Nginx is the actual response time that it took the backend to generate. And with that, this gets parsed as a floating point number and stored in Elasticsearch. And we can very easily generate a graph aggregating that response time for all the log entries. So automatically you get the average response time for your web interface and for the API, just using almost standard Apache logs. So with that kind of setup, you get a request from the marketing team asking you who signed up today. Well, you can just build them a dashboard for signups or for aggregating finance information, like how much income did you generate in the past week or months, or even for support. For support, it's very useful when you get a support request to go and look at what this user did in the time frame that you need to better understand what he did to end up in maybe in a broken state. So that's it about events. Just centralized logging infrastructure. Use StrikeLog in your applications, and then build a great dashboard on top of that. And finally, metrics. So, contrary to events, metrics are time series data, meaning they're continuous, they're updated regularly. Like instead of logs being emitted at any time series data is like you have a point, you have a data point at every interval. A very big player in the metrics ecosystem is the Graphite stack, which you might know about. And it basically consists of 3 different components. The first one is Carbon, the second one is Whisper, and finally Graphite. Let's talk about this in more details. So Carbon is a daemon that listens on a UDP connection, and basically you can send it that data using what is called the Carbon line protocol. And it's a very simple protocol where you just send a line containing an identifier for your metric, a value, and a timestamp. And it's simple enough that you can use it in bash scripts or in basically anything. So it's very easy to emit metrics for Carbon from any piece of software. So that looks a bit similar to our logging infrastructure. We have agents that collects metrics and emits them. And then we send them to Carbon, which then stores them into a time series database. One possibility for that is Whisper, which is a file-based time series database. And then Graphite can take that data and render graphs of those. And for in some cases, we like for when you run a web application and you want to measure like how long a request takes or how long a task takes to achieve. You can't just send a metric because the interval is not predicted. So there is a daemon that's called statsd, and it acts as an in-memory buffer for Graphite. So you send data to it at any time, and at regular intervals, it will flush it to, it will aggregate it and flush it to Graphite. And you can, statsd has counters, timers, gauges, or all sorts of interesting data structures. In Python, it's quite straightforward to use. There are a bunch of libraries. There are Django-oriented libraries that can send request timing data, for instance. So you just decorate a queue with a statsd decorator and then get automatically, it gets the time and sends to Statsy. And then for graphing, we have Graphite, which is basically a rendering API. So it talks to a time series database, and then renders graphs in JSON, PNG, CSV, even Pickle if you want. And one of the strong points of Graphite is that it has a fairly easy to use API and a lot of dashboarding apps. So it has a built-in dashboard, which is not that great, but then we have lots and lots of third-party dashboards that use the render API. The most well-known dashboards are Grafana or Graph Explorer, but there are lots and lots of others. So let's see if we can have it then. So this is simply system metrics that are collected by CollectD, which is a monitoring daemon, and basically tells you every 30 seconds or so all the useful information about machines. So for instance, disk usage, memory usage, CPU, bandwidth, disk I/O, etc. And so this is only raw data coming from the time series database, but Graphite has a very useful set of functions that you can apply to these metrics. So if you want to compute stuff and do some analysis, I don't have enough data here, but you can, if you have lots and lots of machines, there is a function called most deviant, so you can look at those which are not looking like the others, things like that. So this was only for visualizing data, but when sometimes we need to get alerts, like when an app server is overloaded and we need to provision a new one, or when a disk is full, etc. So for that we're using a solution called Remand, which is basically a proxy behind, in front of Graphite. So instead of sending everything to Graphite, we send it to Remand, and then it acts as a in-memory proxy. It does some analysis. Like it can compute aggregate, it can notify you based on thresholds that you define, and then it forwards stuff to Graphite for storage. So it's written in Clojure, and the config file is actually a Clojure file, so you can define your own data processing functions into and add your own logic very easily. Very quick demo because Alright, so that's a very basic Remand dashboard. But what we can see here, I have set up thresholds for disk space, and I set them up at 50% disk usage. And since two machines are above that threshold, they appear in that dashboard. And so when they have a state that's not green, then you can get alerts fairly easily based on that. I guess that's it. If you have any questions,